What is up, amigos? Today we have the aerodynamics of a minion, and this is at the request of one of you amigos called KA830, who wants to make a minion cannon. So you wanted to see how aerodynamic these minions were to shoot them out. So we have this minion here. I think his name is Dave. I can't remember actually. And we have these X-planes downstream. The wake is incredibly chaotic. So you can see like the fifth plane downstream, the wake dances around so much, like almost the entire height of the minion. It just keeps dancing around. So the wake is not very streamlined at all. We can see that it's very bluff. I can tell you that the drag coefficient of this minion is 0.68, so it's quite bad. This is the exact same look here, and we have the sub drag plotted, so the distribution of the drag in these different planes. And if you look at the third plane and even the second plane to some extent, you can see that the left half is quite symmetrical to the right half. There's like this dancing around, but it dances around fairly symmetrically, and then it breaks down three-dimensionally, which means that it becomes less symmetric over time. We have a Y plane going straight through the minion now, and look at the wake, look at the angle that it goes down at. So that indicates that we have a lot of lift being produced, and in fact we do. We have a lift coefficient of 0.49, which means that minions are very well suited to actually flying. All you need to do is throw them fast enough in that direction, and hopefully they stay in that orientation, and they will produce more than enough lift to get off the ground. This is the same plane, but with the sub drag plotted now. And we can see that there is quite a lot of drag just because it's a bluff body, but also there is a periodic shedding of these like little regions of drag, and that is from the von Karman street that we are getting. So this is a bluff body, and it's quite a nice bluff. It's like just pretty much like a pill shape, and that results in a fairly crisp von Karman street coming off of this shape. So this is a Z plane right through the minion's legs, and a couple of things that stand out. One, there is quite a big wake even though we still have the legs, but two, there is this periodic shedding of this wake, and it's not it's not actually symmetric or asymmetric about the or symmetric about the center line. It's more like just these little blobs that come off, which are symmetric about the center line. That is through the three-dimensional effects of the von Karman street in the Y direction, the Y axis, which we saw in that Y plane just before, and that indicates that this shape is pretty much dominated by that direction. So the flow left and right is not really dominating the wake very much. It's more the flow up and down. And this is the exact same plane, but with the sub drag plotted. And this shows to a large extent why this minion is so draggy. I mean, we are just in its feet. It's not over its body yet we still have such a lot of drag being produced behind the feet. And this is what we see in a lot of things that have legs and feet, humans, animals, and minions. So the legs are often very draggy. One way to get around that is to like turn this minion 90 degrees, so one leg is in line with the other leg. This Z plane, which is pretty much going through the middle of the minion, even here we see that the flow is largely dominated by the flow in the up and down direction, not left and right. And the reason why we can see this is because the von Karman street coming off of the left and right side, like that left and right motion, is not that strong. It's more like this blobbing motion that we see where like you just get a little bit of blob forming quite symmetrically about the center line in the y-axis, and that means that that's from the three-dimensional effects from the y-axis. So this Z-plane is just at the top of the minion's head, and the funny thing is that it's going through the goggles, through the minion's top of the head, and yet the wake is still smaller than the wake that we got around the legs. So we have a lot more cross-sectional area here, but the wake is still smaller, and that's because the legs just produce so much drag with animals and humans and etc. The heads are better. And now this sub-drag plane here shows that, okay, there is some drag coming off of the head, but considering how big the head is, it's pretty good. The legs are the part that we need to focus on and streamline those things. So that's in the simulation. Make sure to like and subscribe. And if you want to get better at CFD and theory yourself, check out our course in the lecture. And I'll see you next time. Peace out, amigos.